Yeah, hello everyone. My name is Korczynski. I am a security engineer at Ada Logics, where I do a lot of fuzzing and supply chain security in the open source. I am giving this talk with Laurent and on behalf of Laurent because he couldn't be here today, so I'm taking his part. But fear not, he has had his hands in the slides, so all his good stuff is in there. The talk is about building your own SLSA Level 3 provenance builder on top of a new framework called Build Your Own Builder from SLSA. Quick poll, who here maintains a project that builds software? A lot of people in the audience, very nice. The agenda, quick primer on SLSA. What it is and why it is, why do we need it, or why are people working on SLSA. And then the Build Your Own Builder framework, which is a framework that SLSA released a couple of months ago, 2 if I'm not mistaken. And then finally, building a builder on top of BYOB, or to be specific, building a builder on top of Build Your Own Builder. And Laurent is part of the SLSA team, and he is the one who designed, or part of the team that designed and implemented the BYOB. My involvement in the BYOB was that I built, as far as my knowledge goes, the first open source builder on top of BYOB. So my involvement was more practical, and Laurent was kind of in the back end of the BYOB. So let's talk about SLSA, starting with the software development lifecycle. I'm sure everyone is familiar with this chart here, or something that looks like it at least. We have a developer who maintains a source code, or a developer/vendor, and when the developer/vendor wants to release the project, they build it, package it, and place it in a package registry for the consumer to consume it. Of course, from a security perspective, there are a lot of places where this can, or something can happen in this process. So here are from a couple of steps where an attacker can change or interfere with the whole software development lifecycle between the developer and the consumer. So at step A here, an attacker can attempt to make illegitimate and malicious commits to the source repository and inject malicious code, or not inject, but by way of commits, add malicious code to the source tree. An attacker can also compromise the source repository itself, the infrastructure around it, and inject code that way. Now, when the source gets transferred to the build platform in order to be built, that's also a place where an attacker can interfere. Let's say that so the vendor expects that their code is passed along to the build platform, but an attacker can potentially interfere there and pass along their own malicious code to the build platform. The build platform can also be compromised, and an attacker can compromise the infrastructure and interfere with the code that gets built there, or the output of the build platform. Likewise with step F, also a point in transit for our software project, or for the vendor software project. At this point, we expect that we have built our own, or the vendor expect that they have built their own source code. But if an attacker interferes here and at step F and simply passes along their malicious artifact to the package registry, anything before it doesn't really matter in terms of security. And then we have the package registry at step G. Sorry, I should include step E here. When we build our project, we pull in external dependencies. An attacker can also compromise these and simply add malicious code to that gets run when the consumer consumes the artifact. As step G, the package is stored at a package repository, package registry, and an attacker can compromise that registry. And again, if they are able to do that, they interfere with the whole process. And even if you build your own you build the package that you expected to build, or the vendor built that package that they expected to build, and safely transferred it to the registry, compromising the registry, the package registry, includes results in a compromise of the package that they can then make malicious. Finally, the consumer pulls the package from the artifact from the package registry and consumes it. And that's another transit point where an attacker can interfere and simply send another package to the consumer, such that they consume the attacker's malicious package instead. Now, SLSA, I should say that these are areas where an attacker can interfere, but I believe all these steps, we have real-world examples of attacks in the wild of all these steps, so they can and they have already. And this is something that the SLSA framework works on mitigating, securing the supply chain from the vendor all the way through source, build, package, the package registry, including the dependencies that get pulled in, such that the consumer can be sure that they consume the artifact that the vendor intended that the consumer consumes. So SLSA's framework for evaluating software supply chain security is open source, maintained by the OpenSSF. It has the goal of ensuring integrity and tamper resistance of a project. Basically what I just said, that the consumer consumes the right package. And when we talk about tamper resistance at a high level, we talk about tamper resistance of the source code, that it's properly configured and you can't really, or you can't compromise the platform itself and the source repository itself, and or that you can't make malicious code commits. This is kind of a no-brainer, but there are actually real-world examples where proper code reviews could have caught serious breaches. Then we have the binary, the tamper resistance of the binary representation itself of the artifact, and a couple of important parts of that is that the build platform, the build platform on which the build runs is ephemeral and isolated, and naturally, if the build environment is not ephemeral, it's reused, it becomes increasingly easy for an attacker to interfere and download or interfere at one step, which then gets passed on to subsequent builds. And isolated, of course, that you can't interfere with the build process itself while it's ongoing. And all of these things make up 4 levels in SLSA, and the higher the level you conform to of the SLSA framework, the higher software supply chain you achieve. So SLSA uses, or let's say that you do want to conform to SLSA principles or the SLSA framework, and to communicate and prove that you do that, you use a transcript. And SLSA uses a provenance file here of the in toto project. And let's go through here. So a couple of things to note of the provenance is that you have the SHA-256 value of the binary itself, and you have the source code that got built, that you built this binary with, as well as the entry point of the workflow that you invoked to build the binary. So with this, you can verify that the binary is the one that you're consuming, and if you see anything wrong or anything weird in your invocation of the binary, you can go back to the source, to the exact commit, the digest, the SHA-1 value here is the commit, and you can do your own checkup on it. Now, pre-BYOB, SLSA users were expected to do everything. So the projects, the software projects, were expected to build a project and generate provenance in a safe way, in an isolated and ephemeral way. And that's a lot of work. That could easily take a couple of months. And we are talking here a couple of months per project, per SLSA user, which is a lot of time and hard for kind of a blocker for adoption. So this was a motivation for the SLSA framework to come up with this new idea of the BYOB framework. I'll get into that in a second, but SLSA based their BYOB framework on GitHub Actions because it naturally adheres to a lot of the principles of SLSA, ephemerality, for example, and isolation. There are also some commercial products that do that. Google Cloud Build is an example of that. So this is just another inclusion in the provenance of the builder that you use to build your software project. So at a high level, one-liner, what is Build Your Own Builder? It's a set of GitHub Actions and workflows that packaging maintainers can use to invoke or to build and generate, build a project and generate provenance. And one of the strong advantages of BYOB is that it takes care of a lot of the tedious and problematic parts of building a project and generating provenance in a secure way. Who's it for? Primarily Action developers and maintainers. But the goal is, of course, to get provenance out to and SLSA level 3 compliance out to as many users and SLSA adopters as possible. And I have included it here because the BYOB also makes it very easy for software projects to adopt SLSA. I'll show that a bit later. So let's look at a high level of the BYOB from the user's perspective. Project maintainers or maintainers maintainers of projects that are user-faced. So any project out there, talking Kubernetes as examples. So when a software project wants to release, they do it on GitHub Actions. They do it by way of a release.yaml file. And now with BYOB, the users interact with a builder workflow. And this is a workflow, think for example, Go releaser or J releaser. They, instead of first building and then later building the provenance, they now interact only with a builder workflow that does both things. So the builder workflow does primarily takes two steps. It initializes the BYOB. And it does that by passing along a builder action such that the BYOB SLSA workflow knows how to build the project. So when initializing, the builder workflow passes along a build action to BYOB, and the BYOB backend remembers that for later. Having done that, the builder workflow invokes BYOB. I'll get a little more into how later, but at a high level, initialize and run. And when the builder workflow runs BYOB, the BYOB workflow, the SLSA BYOB workflow, then builds the project, referring to the builder action, and then generates provenance, which is passed along with the output artifacts back to the builder workflow, and finally back to the user. So let's look at how to write a builder workflow. And this was primarily my practical part of the BYOB. I built a Maven and a Gradle, one Maven and one Gradle builder workflows that built a Maven-based project and then generated provenance, and the same for Gradle-based projects. So to initialize, you make a call to this GitHub action, setup generic, and the SLSA runner label. I'm not sure that's mandatory, but you pass along the build action path, which is a path to the action that builds the project, and you pass along some inputs that you need for your builder. And then to run, you invoke this workflow, delegator generic SLSA 3 at the SLSA GitHub generator repository. The secrets are, again, optional, but here I demonstrate that you can't pass along secrets. You can also pass along inputs based on what you need. We have this token. This is our SLSA setup step. And here, or job, and here this one gives us a token back, and we pass that token on to the delegator. So let's look at the builder at a high level. I think we have here 80 lines of code, including license header. I define some inputs. So this is my Maven builder. I define some inputs. Optional based on what you need. Most of them. There are some mandatory, I believe. The recall log public is actually only required for private repositories and is default true on public. And the inputs are not important, just to demonstrate what I needed for my Maven builder. So the outputs as well, also specific to the Maven builder that I built. It's mainly file names of the output artifacts and the provenance. Then I initialize the delegator, pass along some arguments, and finally I run the delegator. And yeah, so when I initialize, we see this SLSA build action path. That's a path to a repository that has my build action. It's done this way. Yeah, very easy if you ask me. And that makes up the builder workflow. Now let's look at this build action because that's the one that builds the project itself before generating provenance. So yeah, the build action is this one highlighted with this pink color here. And yeah, let's dive in. I think it took me 120 lines of code to do the build action. So in total, we are on 200 lines of code. Let's go through it. We have the inputs, and the SLSA workflow secrets are mandatory. I think they are placeholders in case you need them. I didn't. I think the inputs are, yeah, they were. So I passed along a JSON inputs in JSON format here. and that's all I needed for my builder, for my Maven builder. Then the outputs names that I then get passed back to the builder workflow. So I set up my workflow here through. So I set up Java, I set the version, and check out the repository. And I have a couple of arguments down at the bottom: the source reference and the path to the directory that contains my Maven-based Java project. I do a little bit of input validation. That's not mandatory. You can do some security hardening if you want to. This was just for path traversal because I pass along a directory containing the source code. So in case an attacker wants to try to do some path traversal, I prevent that. And finally, I built the project using Maven package, move it out to the GitHub workspace, and I upload it such that it becomes available for the user. And finally, let's look at it from the user perspective. The user who wants to build and to package their Maven project and include provenance, which is the one all the way out there in the left, marked with pink. This is how they do it. They just basically they invoke the Maven builder, and in return they get their artifact and their provenance. So we can see here it's instead of this user spending months to develop an action or a whole workflow that does this, all they have to do is invoke the Maven builder. I do want to say that the SLSA framework also has a verifier for this, so it's kind of a side note, but the provenance is machine verifiable, and the SLSA framework offers a verifier that I wrote kind of a Java Maven plugin with that, so also useful to include. But here's some good links to keep in mind. If you want to build your own builders, like I did, then you can look at the examples of the Bazel container, Go, Gradle, Maven, and Node.js builders there, and the JReleaser as well as a proof of concept. And also the BYOB backend repository has a lot of documentation as well. And yeah, I should say that the SLSA maintainers will be very happy to discuss and help out. So feel free to open issues and or create pull requests or ask questions. Cool. Thank you very much.
We have time for one question. Anyone in the audience? Okay.
Hello. Do I understand correctly that the BYOB backend obviously depends on GitHub, who provides this I think you called it a trusted builder, and you mentioned GCP as another one of these trusted builders. Did I understand that part correctly? And then two, it mentioned a small number of trusted builders, and I wondered whether is that an intentional feature of the system there? So I want to know if I've understood that there's this the same way you have in any security system, you depend on something that's known secure. I want to know, is the small number kind of an intentional part? Do you see that as part of the security of the system that the trusted build part can be performed by two very large tech corporations, for example?
Right. So that's more of a it's kind of out of the hands of the BYOB. That's just a property of GitHub Actions and the Google Cloud build. Right. Pleasure.
Thanks, Adam, for the talk. Appreciate it.
Thank you.